guys, good morning. I thought that the lessons that I would give you today would have to do with, there are a few word problems that are going to involve angles of reflection. And so, anytime you deal with something that's going to be bouncing, this could be a basketball bouncing off of a backboard, this could be a billiard ball bouncing around the table, or just an everyday math problem, word problem. You're going to encounter this kind of thing. So in one of your problems, they are going to have two parallel walls on a pinball machine. And then this particular ball is going to come bounce off here, and then it's going to come to the other side and bounce off again. And so they're going to be asking about the angle of reflection. And basically the only thing that is going to be necessary or consistent throughout this whole thing is a pretty simple principle that whenever you have a flat surface, whatever angle the bouncing object comes in at is going to be the exact same as the angle that it exits at. And so you can kind of notice, if I come in at a really low angle, I'm going to be bouncing this ball, a silly buddy. If I come in at a really low angle, it should come up at a really low angle. However, if I come in at a really high angle, almost 90-degree angles, it's going to come up at almost 90-degree angle also. So the stronger the incline going in is going to be the stronger the incline going out. And mathematically speaking, they're actually going to be equal to one another whenever I can have a perfectly round ball. So in the problem that you have in your classwork, again, there was two walls to bounce off of, and this particular one comes in at a 72-degree angle. So whenever it bounces off, it's going to have another 72-degree angle here. And then it's going to bounce off of that wall. And they're going to be asking you for this angle. So there's several things going on. Now, since these two walls are parallel to one another, that makes a transversal. And so if I were to extend this line and extend this line, then we could make this a little easier to look at. And this becomes a transversal, where we have 108 degrees, 72 degrees, 72 degrees here, and 108 degrees here. Because there are only two numbers out of the whole four, if you count the outside, really 8 angles here. And so if that's going to be 72 degrees, going back to the reflection has to be equal. So this has to be 72 degrees also. So you'll be working on other problems like that, dealing with angles of reflection, and I just wanted to give you a heads up on it. I hope you have a great day, and I'll see you guys next week. Bye.